Non-periodic. Which does not repeat itself at regular interval of time. Simple. Regular interval of time. Then we have left with what? Whatever motion we left with?
Sir, uniform and non-uniform motion.
Yes, uniform, non-uniform, circular, rotatory.
Sir, circular we discussed on that day.
No, that is curvilinear motion.
Yeah, in translatory motion, curvilinear and rectilinear.
So, rotatory motion.
Sir, until now, what did you discuss before I came?
We were discussing about this motion only. Yeah. Someone say about this rotatory motion?
Sir?
What's rotatory motion?
Can you repeat, sir?
What is rotatory motion?
Can I say, sir? Sir, rotatory motion is the motion, it means when a body rotates on its own axis, it will be there. Like a spinning top or rotation of the earth, object which spins on its own axis in a rotating manner is called rotatory motion.
Yes. So it will rotate in its own axis.
Yes.
So its axis of rotation is fixed.
Yes.
Now, circular motion.
So can like a fan come on the rotation?
Sir, rotatory motion definition, can you write like in proper word?
So like can you like fan can come on the rotatory motion?
Sand.
No sir, fan.
Sun. Sun is not rotating. But yeah, if you assume that, yes.
Sir, it is moving on its own axis, so sir, it is rotating.
Yeah. Rotation or about its own axis. So it rotates about its own axis. So as she said, okay, sun, Earth is rotating about its own axis.
Yes.
For us, Moon is rotating about its own axis. Okay, for other galaxies, like it's rotating about its own galaxies. This is like infinite loop.
If it doesn't rotate?
So this is all infinite loop.
Sir, but in rotatory motion, we can't specify it as an object, no, sir?
No. We can, why not? If anything is rotating
But
about
Earth
its
is not
own,
an object, no, sir.
we can assume this is the object, it's rotating about its own axis.
Okay.
Spinning top is the object. Okay. That is your rotatory motion. What about circular motion?
So moving in a circular path,
Yeah.
like the motion which like takes place like when the object moves in a circular path.
Motion in circular path. This is, we can assume this is a circular path, it's moving, Earth is moving around.
So like Earth is moving around the sun with like revolution.
Yeah, no, that is also okay. Now, again, same question, can rotatory motion be a circular motion?
Yes. Sir.
No, sir. Circular can be rotated. Sir, I have one doubt.
Yes.
In the previous class, you made us get confused for one question.
What is it?
Yeah, that vibratory part. All vibratory.
Ah,
Oh, we already discussed that. No?
Sir, tell the answer.
yes. My sir, if I ask my mom and dad, they are giving me two different answers again.
Okay, what are that?
No, sir. Like one is going with the question. I don't remember.
Can
Vibratory motion.
all rotatory, sorry.
Yes, sir, can like some vibratory. So tell the answer of that, please.
Can all oscillatory motion be vibratory motion and vice versa?
So,
It's no.
I was going with all. No, yes, sir. All oscillatory are vibratory, but not all
Sir,
vibratory
I
are
was
oscillatory. Was what I was saying.
doing the opposite. Yes, sir.
I
Sir, I'm doing
all
the
oscillatory
second
are
one.
vibratory.
So second one.
Second one is not possible. All vibratory cannot be oscillatory.
Sir, I did it.
If I give you example for each, all oscillation is vibrating. Anyhow, vibrating of object is oscillation. But if I assume vibration of any string, guitar string, if I assume that's vibration, it is also vibrating. Or tabla, if you're just banging it is also vibration of that, what is it called? I don't know name of that tabla portion.
Diaphragm.
No, the central portion. There's some particular name, I don't know. Whatever it is. If you bang this one and air around it, it get disturbed with that. So that makes a sound with the help of this compression and so this vibratory cannot be oscillatory. But oscillatory can be vibratory. Can. There is a question mark here. Can be. Or it may be.
Sir, can you like give an example like vibratory motion that is not oscillatory?
That's what I gave just now. Guitar string. We are playing guitar. What we are doing, we are disturbing that string which makes sound. Which is amplified by thing whatever it is. That is not our problem. But it is vibrating. It is not oscillating there. In this case, in drums also, it is. In drums also, it will vibrate this portion and amplify by this part. Okay, that is not our problem. But still, it is vibrating, but it is not oscillating.
Yes, sir. In a guitar, sir, like there isn't a like huge to and fro motion, like a longer one.
Yeah.
Sir, I think like the moment of pendulum is like oscillatory, so that cannot be vibratory, right? Sir?
It is vibrating if I say that. It is displacing from its position and vibrating. It's very big vibration.
Okay, sir.
Your guitar string, it is vibrating like this. Okay. So, everyone cleared their answer? Yes, Ananya?
Yes, sir.
You're saying
Sir,
something?
on that.
I cannot hear
Sir,
that.
on that day, when I said all oscillatory or vibratory and everyone, almost everyone were opposing it, I thought it was wrong, sir.
No, no one was opposing, is it?
Yes, sir, but I said all oscillatory or vibratory, but when almost all of them said all vibratory or oscillatory, I got confused and I thought maybe I am wrong. But I stood with what I am.
अच्छा ठीक है no problem Yes.
I didn't understand the circular motion. Can you tell me?
Sure. Okay,
Okay.
circular motion is what? Motion in circular path. Simple. It's just we are moving in a ground and running to the track. That is circular path. So just keep moving in circular path. That is your circular motion.
Sir, what is the difference between rotatory and circular motion?
Same difference, which is having vibratory and oscillatory. There is no difference.
I didn't get it.
Example of circular motion.
Like, not like circular is same like curvilinear, right?
Yeah, but curvilinear is curved path. Okay, curved path which is moving in a straight direction.
Yes, sir. It's like curved path. And this is
Sir, I
like
have a doubt.
You know?
Sir, can you give one example each for curvilinear, rotatory, and circular motion?
Okay, let me show you a photo. Rotatory, curvilinear, we already saw that. Let me show you a photograph for.
Sir, no, like one example for each.
Yeah. Let me show you a photograph. In short, it should keep fixed distance. That's it. See, I got perfect difference between circular and curvilinear. Sorry, circular and rotatory. Oh, where it went, photo. Oh, this is not a photo. I'm sorry, I need to change screen. Wait. Can you see this? Can you see the screen?
Yes, sir.
Okay. See this. We are not going on tangential velocity first because this is some 12th standard portion, 11th standard portion. We're just seeing this part. Can I highlight here? This one. See this rotatory motion about its own axis, right? In rotatory motion, we are just concerned with its axis of rotation. Can you see this?
Yes, sir.
Now, in circular motion, we are concerned with circular path. See that it's making it fixed axis. See this? Fixed circle everywhere. Fixed distance. I want you to observe this and this diagram. Means like it's not diagram. I think it's a GIF. Not even GIF. What is it? Okay, it's a stickman. So, can you observe this? Are you able to understand now? Difference between rotation and circular. In this one, we are just worried about this axis of rotation. Here we are worried about circular motion. Yeah, see, it's making it fixed circle. Clear? Everyone?
Yes, sir.
yes.
Shall we move back to our screen?
Yes, sir.
अनन्या?
Yes.
ठीक है. And Nityashri?
Yes, sir.
ठीक है. Any other?
Sir, I actually joined late, sir. What were you telling?
We were discussing about rotation, rotatory motion, and circular motion. This is your rotation, rotatory motion, which is about its axis. In rotatory motion, we are just worried about its axis of rotation. This is your axis of rotation. In circular motion, we are worried about this radius will be fixed. Just
So that
one
means it's going in a circular path and in the rotating
Fixed.
motion is revolving around itself.
Yeah, that's what the difference is. Okay,
Sir, can you scroll a little bit up?
this is what we started from. Here we started.
Only this.
Yeah. Oh yeah, we wrote non-periodic motion.
Okay.
So for your answer, that is, can oscillating motion be vibratory? Yes. Oscillating.
Sir, I'm still not convinced with this.
Why? What happened? Tell me your views. Why you are not convinced?
Sir, what is the conclusion of this, sir? Oscillatory motion and vibratory.
This conclusion I gave as all oscillatory motion will be vibratory, but all vibratory cannot be oscillatory.
Okay, sir.
Yeah, but Sahu, why are you not convinced? What happened? You tell me.
Sir, vibration is rapid, right?
Yeah, it's rapid.
And oscillation is generally low speed than vibratory.
Yeah, that is true.
But the basic concept is same, that to and from motion
Yes,
about
sir,
its
that's
equal
right. The
distance.
simple pendulum, sir, it's like an oscillator. It's not a rapid to and fro. So,
Yes, sir.
Yeah, that's true.
sir, and guitar, it is a rapid to and fro, but still it has to and fro. So it is oscillatory and vibratory.
Yes, sir. So we can't say that the pendulum is vibrating or the guitar string is oscillating. I mean, we can say that the guitar string is oscillating, but we can't say that pendulum is vibrating.
So you mean vibratory motion can be oscillatory? That's what you mean.
Yes, sir. Because the basic idea behind the both is same: to and fro motion about its mean position.
But vibratory has rapidly. Oscillatory doesn't have to do anything with rapidly. So that's the reason all oscillatory are vibratory, but not all rapid to and fro are oscillatory.
Not that, Nityasri. But see, yeah, Sahu, yeah, as you're saying, it's correct. Okay, but why I said this? Because see, if I think about oscillatory motion, we just focus on to and fro motion, right? Now, when we are talking about vibratory motion, we are talking about speed actually, how fast it is vibrating, how fast it is oscillating. Vibratory motion is oscillatory only, but how fast it is oscillating. That is all about vibratory motion. So that's why I said all oscillatory motion will be vibratory. But in the case reverse, which is
Sir,
Yeah.
I wanted to add a point.
yeah, sure.
Sir, in geometry, in maths, we say that all squares can be called as rectangles, but rectangles cannot be called as squares.
All squares can be called
Yes, sir. All the
Sir, so
squares
the
can be
same
called
way-
as a
Yes,
rectangle.
sir, but not all rectangles, because square has all the rules of the rectangles, but the rectangle doesn't have all the rules.
Yeah, all sides are not equal.
Sir,
Sir,
here I
either
want
we have to
Sir,
say
no,
that
no, no, sir.
oscillation.
That's not the point, sir.
Sir, even I had to add a point here. If squares and rectangles did come, all natural numbers are whole numbers, but not all whole numbers are natural numbers. Only because of the number 0. In the same way, all oscillatory are vibratory, but not all vibratory are oscillatory, because it also depends on the speed in vibratory.
Okay.
Sir, speed can be called as a secondary characteristic. The basic idea is same.
Yeah.
Means to and fro motion about the mean position, which is same
Yes.
in both the cases.
Correct. Which is same in both cases. So
So, sir,
in
hence all vibratory are oscillatory, but not all oscillatory are vibratory.
okay, first
Sir,
tell me.
even me, sir, I'm not convinced.
Okay, let's say what is oscillatory then? First, just give me a term. What is oscillatory?
To and fro motion about a mean position.
Okay, to and fro motion about its mean position.
Yes.
And what is vibratory?
Rapid to and fro motion about its mean position.
Yes, sir. Rapid to and fro.
Rapid to and fro motion. Right? You got it? Rapid to and fro motion. So rapid oscillatory motion is vibratory motion. Can I say that?
Yes, sir.
Let's conclude. Right? Rapid oscillatory motion is vibratory motion. Yeah?
So here we come to the conclusion. Rapid oscillatory is vibratory,
Yeah.
not oscillatory is vibratory.
Okay, then let's right here. Rapid oscillatory motion is vibratory motion. Right? Anything else we can add here?
Yes, sir.
What else to add here? Anything? No? Yeah, someone want to add? Okay then. No one wants to add something? Shall we go to next topic?
Okay.
Yes, sir.
Yeah, Mr. Shahu and Lalit, are you convinced now? Or still you have some points to say?
Sir, I still have, but it's okay. We can.
No, it's okay. I like discussion. I like debate. No. Oops. क्या मजाक हो गया ये तो. एग्जाम्पल नहीं देता. हाँ? एग्जाम्पल का है क्या? तो कुछ बोल रहा. हाँ? टू एंड फ्रो मोशन क्या?
Sir, can you hear?
Can you all hear me?
Yes, sir. We can.
Yes, sir.
Oh, great. I'm back. Oh, did I miss anything? You were having some discussion?
No, sir. Welcome back, sir.
No, sir, you missed a lot.
Yeah, I was asking Sahu and Lalit something. Did you reply anything? I didn't hear. Sahu, Lalit?
No, sir, it's okay.
It's okay? You should not give up like that. You should not give up like so soon. Check. Okay, fine. Then let's go with rotary done, circular done. Okay. See, we just discussed about what types of motion we can have, like circular, uniform. Yeah, uniform. What is uniform motion? What is uniform motion?
I didn't hear you.
What's uniform motion?
going a straight path, going at a straight path in one particular.
Sir, when
Sir, like
sir,
a motion in which an object covers equal
sir,
distance.
when an object covers equal distances in equal intervals of time,
Yes.
it is said to be uniform motion.
Equal distance in equal interval of time. And what is non-uniform? So non-uniform is unequal distance in equal interval of time. Simple, right? Okay. So we can have discussion on distance now. Distance and displacement. What is distance now? Can you all hear me?
So the length between the two ends
Yeah.
is called as.
So like distance is actually the actual path covered by an object.
Yeah. It is actual path.
Covered by an object, sir. And then displacement is the shortest part from the initial position till the final position.
Covered by object. Yes. And displacement is shortest path.
So
But
displacement.
I think, sir, like we don't actually write distance. We actually write distance covered in science.
Shortest path between the two endpoints is called
Yeah.
displacement.
Exactly. So we can say shortest path or
Shortest part from the initial till the final point.
yeah, difference between first final and initial point. We can say that difference between final and initial point. Okay. Now, which one is scalar quantity? Which one is vector quantity?
The distance is scalar.
Distance is scalar and
Displacement is vector.
So if it is scalar, that means it will be always positive.
Are only magnitudes, sir, and then it's always positive. It cannot never be zero. But displacement can be positive, negative, or zero.
Okay. It can be positive, negative, or zero. Okay. Now I want someone to give me.
So distance is denoted by D and displacement
Yes,
by
ma'am.
S.
Displacement is smallest.
S. Yeah. Fine. I want someone like let's say. Yeah, Vedika, are you there?
Yes, three.
Vedika.
Yes,
Okay. I want you to give an example where there is a negative displacement. When you can have negative displacement?
Sir, when the when an object moves opposite from its initial position,
Okay.
So I did not get the question itself, sir.
I want one example of negative displacement. Positive displacement, okay. Zero displacement also okay. Like positive displacement means this from here to here, we are moving.
Her example was correct only, sir. Like going in the backward direction from the initial.
Yes, sir. Like if there is like going backwards, suppose like one person was walking and then he went backwards. So the displacement is negative, but the distance is always positive.
Okay, so this is your starting point, as you're saying, going in this direction.
Yes, sir.
But if I face this side and walk this side, then it will be positive for me now.
Sir,
So, but
one
according
side
to
is
graphs, the
positive,
left
one
side is considered
side.
as negative, right?
The
Yes, sir.
left
That's what
side
the
and
right is
back side,
actually
sir.
positive.
Left we are walking rightwards, then it is negative.
One second, like one by one, please. Yeah. Vedika, yeah, you're saying something? Continue.
Yes, sir. According to graphs, the left side is considered as negative.
Okay. And right side is considered as positive. That's what?
Yes, sir.
Right side and up.
Sir,
The
honestly,
zero
can
will
you
be
give
like the initial point.
Okay.
sir? Can you
Yeah.
give a small example? I mean, one example, sir.
Sure.
Yes, sir. Sir, like if like for the people those who are in the office, sir, or even if the school children in the school, like when they get out of the lift, but then they find out that this is not the floor they want to be in, they go backwards into that same place. It is a short distance, but then it's going backwards. They go back inside the lift.
Okay. Anyone else want to share your views about displacement? Let me hear. Yes, Jasmita?
Sir, actually, I think that if we are turning towards one side and relative to that side, for example, if I'm turning towards left and I'm walking right, then it will be negative.
What is the last statement? Say that again. When it will be negative?
Sir, I said that if I am turning towards left and I'm walking towards the right side, that means according to my turning, I am walking backwards. So that is when it is known as negative displacement.
Okay. Yeah. Sweet. Yes, Adya? Okay, anyone else? Want to share your views about this one?
We'll go with her, sir.
It's nothing like right or wrong answer. Everything is right.
Sir, can you once scroll up?
Sure. Okay. So suppose if I'm starting from here and I went there of C position and this is D position and I stopped here. So will it be my negative displacement?
Yes, sir. It will be negative because the shortest path. Yes, sir. But the displacement will be like positive. How much actual path?
So displacement will be negative or positive displacement.
The negative displacement.
And if I reach A, it will be
Zero displacement.
exactly right. So if a starting point and initial point is same, that means there is a zero displacement. Simple. Okay. Now this is also depends upon reference of position. Depends upon reference of position. Where person is standing, how is looking, and what is the position of the object. Okay. That is called a reference frame. Reference frame. See, this reference frame is very, very important. It depends from where we are looking. Suppose we are standing here and like as a standard example, train is passing through it. We are standing on a platform, train is passing through it. It depends, right? Person is moving with respect to us, but with respect to train, he is not moving. He's steady. So it depends. What is the reference frame? Yes, dear, tell me. Can you what? Okay, I was just talking about reference frame. Reference frame means like with what we are comparing. What is our reference of comparison? Like as I gave just now example, like we are standing on a platform and a train passes through us and some person is sitting there. So for us, everything is moving together. But for train, person is rest. He is not moving. But for us, the person is moving. He is not at rest. And if we assume
Sir, can't we say the train is only moving?
train is moving, but person is not moving. That's what I'm saying. So as per this person, what is our position? The person who is sitting on a train, this guy, let's name it A. In the reference of A, what is B position? Is he moving? Is he steady or something else?
Is moving.
Is moving?
Moving, sir. Because as a train is moving, they also feel like the people on the platform are also moving in the opposite direction.
So he will observe that. No, you go first. Give me, then I'll say answer. Anyone else want to share an answer? Yes, people, tell me.
Sir, for the person B, the person A is on the rest. But for person A, with respect to the people in the train, he is in rest, and if he is out, he is on motion.
Yeah. Yeah. Good. I want to hear from one or two more guys. Come on, people. Vishnu, you didn't speak anything. Yeah. What do you think about this? A, with reference to A, what will be B position? Will it be moving, steady, or something else? Vishnu? Not there, Vishnu? Okay. Then Datri, you there?
Hello, sir.
Yeah.
Sir, I'm trying to reconnect again and again. I just rejoined. Can you?
I can see that. Okay, Sahasra, you're with us? Sahasra, are you with us or not?
Yes, sir.
Okay, good. So tell me your view about this B. What do you think? According to A, B is in moving condition or a steady condition? Or something else?
So,
Yes, dear. Yeah?
so will you repeat the question once?
Yeah, I'm asking that, like, according to A, the person A who is sitting A, he's inside the train. According to A, what is the condition of B? Is he moving? Is he steady or something else?
He's moving.
He's moving. Which direction?
So,
Look at the keyword over there now.
Sir, can we play a quiz?
Sure. Can. Yes, dear. What do you think it's moving in opposite direction or same direction?
Sir, it's moving in opposite, sorry, same direction.
No, think again. See, train is moving this direction, then obviously it will be moving. We will observe that if we are A, imagine if you are sitting inside train, and what you will think of this person who is standing on the platform, they are moving backward direction, right? That
Yes,
means
sir.
we will
Sir,
observe.
opposite direction.
Yes, they will be opposite direction. That means they are facing what? Negative displacement. Can we say that?
Yes, sir.
Yes, people, can we say this? Is this a negative displacement? According to us, according to A. Is this negative displacement according to A? Can we say that?
Yes, sir.
Yes or no?
No, sir, because it is coming from B, sir, na, not from initial point, which is A.
No. I'm saying according to A, B is facing negative displacement. According
Ah.
to A.
Yes, sir. Yes, sir.
Yeah? Are you getting my point? What I'm saying?
Yes, sir.
Okay. Fine. So let's end this discussion and let's have some quiz. What topic shall we have today?
Motion, sir.
Motion. Acha.
Yes, sir.
Motion, the motion. Sir,
Oh,
then it's your wish. Motion, do something fun also. Then it's your wish, sir.